Good afternoon, everyone. Wherever you are in the world, I hope you and your loved ones are healthy and safe. My name is Randy Bell, and I'm the director of the Global Energy Center at the Atlantic Council. Thank you for joining us today for EnergySource Innovation Stream, where we highlight new energy technologies with the potential to reshape the global energy system. Today, we'll be hearing from Pratik Chandhoke, Technical Manager for Renewable Aviation in North America at Neste, for a discussion about how Neste's renewable jet fuel can help decarbonize air travel and reduce greenhouse gas emissions in the industry up to 80% when compared to fossil fuels. Before we get started, two administrative details. First, you can follow us on Twitter at AC Global Energy and use the hashtag InnovationStream. Second, after Pratik's presentation, you can submit questions through the Q&A function on Zoom, and I'll try to get to as many of these as I can. If you're watching on another platform like YouTube, unfortunately, we can't take your questions. So please let me welcome Pratik Chandhoke to the Atlantic Council. Pratik, thank you so much for joining us, and I need to wish Pratik a happy birthday today, and note that this is also his first virtual presentation, so no pressure. So Pratik, how are you celebrating your birthday today besides the innovation celebration event?
Well, thank you, Randy, for inviting me to this webinar, first of all, and hi, everyone. I'm feeling great, feeling young again. It's been quite a couple of months because of the COVID situation, so plan is really to stay at home and enjoy with my family.
Pratik, and you're down in Houston, right?
Yes, I am based in Houston, yes.
Yeah, so it's the rough time down there. So I hope that you and everybody is staying healthy and safe. I know we're going to talk more about COVID and its implications for the aviation industry in a little bit, but
Right.
why don't we get started with your presentation, and
Sure.
we will chat more afterwards. For everybody, use the Q&A function if you want to ask some questions.
Okay, so I will start. I have a little presentation that I will give on SAF, basically going a little bit into the technical details and how is it produced and how is it delivered to the end customer. And I will also go over a little bit of our commercialization efforts at Neste. So with that, Lauren, would you be able to advance to the next slide? Okay, so first off, I will start out with who Neste is. Neste is in the business of fighting climate change. Our organization has been around for a long time, Neste Oil, but it was only 15 years ago or so we started our transformation to produce renewable products, and our first product was renewable diesel, which has been a great success so far and also reduced a lot of greenhouse gas emissions. So we produce, we are the world leader in making renewable diesel and now have ventured into sustainable aviation fuel. In 2019 alone, we saved 9.6 million tons of CO2 reduction with our renewable products. And our ambition is to get to 20 million tons of CO2 reduction by 2030. So what I have on the screen right now is what is very dear to us. It's the circular economy. So we take and collect these waste and residues and turn them into premium fuels, just renewable diesel, sustainable aviation fuel, and then we send that out to be used by commercial trucks, planes that can run on this fuel. So what we're doing here is kind of creating this circular loop of using waste and then bringing it back into fuel. In aviation, for example, at airport, we can collect the used cooking oil from the airport, bring it into our refinery, and then change that into aviation fuel and bring it back to the same airport. So it shows you how strong this economy can be when it comes to recycling and reusing the carbon. So next slide, please. So what is sustainable aviation fuel? It is a fuel that is made up of 100% renewable low-carbon feedstock. It is a liquid hydrocarbon fuel, chemically similar to fossil jet. When it can be used as a blend up to 50% and can be used 100% as a blend in current jet engine technology and infrastructure. It is, when blended, it is similar to fossil jet. It is certified similarly to fossil jet. It's a 1655 ASTM standard that it is certified to. Obvious advantage here for SAF, it is less greenhouse gas emissions and less pollution. SAF is like jet fuel, but it does not have the aromatics. That is the main culprit when it comes to pollution. When you combust these aromatics in a jet engine, for example, it produces these particulate matter that causes pollution and all kinds of health issues. So that fuel, SAF, does not have any aromatics. It's a low aromatic fuel. It's a certified drop-in solution that is available today. It's not a myth. It is not years away. It is available now, including Neste, and there's been a lot of other producers of SAF that are making this fuel. For Neste, we have already started sending this fuel out to the markets. We partnered with AirBP, which was a great partnership for us with an oil major, and just tells you how important it is, everybody, to achieve sustainability in jet fuel. Even the oil majors are willing to participate and make this a more sustainable, make it more sustainable. Not only AirBP, we also have put our blends now on airplanes. So airlines have used them, KLM and Lufthansa, to name a few. Use this fuel at their airports in Amsterdam and Frankfurt. So if pre-COVID, if you have been to one of these airports, you probably had some SAF blend on your flight. So another question, why do we need it? So the chart I'm showing you now is the ICAO CORSIA chart, where you can see from 2020 onwards, there's a huge spike in CO2 emissions, almost 3 times more than what it is now. This is attributed to the tremendous growth of this sector. But thankfully, we have some measures to combat this rise of CO2 emissions. What ICAO defines as basket of measures. So one is operational improvement. By that, I mean using one engine taxiing in and out, or using power at the gate instead of using APUs that require fuel. So if you can reduce the fuel consumption, you can reduce the emissions. Aircraft technologies change dramatically. You have very light material used in aircraft to reduce fuel consumption. On the jet engine side, there's a lot of measures being taken to make it more fuel efficient, like using lean combustion technology. But SAF, with its potential of tremendous greenhouse gas emission reduction, is a big part of that equation to get to carbon neutral growth that ICAO has defined. So it is a very important part, and that is why we are here, Neste and other producers, making this fuel so we can start decarbonizing this sector, which has very difficult time decarbonizing. There's not a lot of options for decarbonizing. There's not a huge battery you could put on a plane in the foreseeable future. Hydrogen is being talked about, but it's still a couple of years away, even decades away for commercialization. So we need to find a solution now. We need to find something that can be used now, that can substitute these liquid hydrocarbons that are being pulled out of the ground and being combusted, and having something that is more sustainable. A sustainable solution is required, and that's where SAF plays a role. Next slide, please. So I talked a little bit about the greenhouse gas emissions reduction potential. SAF can reduce emissions up to 80% in neat form when compared to fossil fuels. All SAF is doing is using this renewable existing carbon. It's recycling it and not putting more carbon into the atmosphere. On the other hand, fossil fuels just take carbon out of the ground, stored there for millions of years, and then increasing that atmospheric carbon levels. One thing I would like to point out here is that SAF does not directly reduce CO2 emissions when it's combusted with the blend. That is, it will emit the same level of CO2. It is over the life cycle of the product that we define this 80% greenhouse gas emissions. Next slide. So I talked a little bit about what SAF is. I now will talk a little bit about the feedstocks. So there's a variety of feedstock that can be used at the moment for Neste's technology, which is HEFA technology, hydroprocessed esters and fatty acids. It is one of the 7 approved pathways by ASTM. So what we use is oil residues, oil, fats, waste oils, fats, and greases. And these waste oil, fats, and greases are available in abundance. In fact, in North America alone, it's a 3 billion gallons of co-generated. And this used cooking oil is basically oil you get from all of the frying of those comfort foods we know and love. It's the pizzas, the hamburgers, the cheese, the hamburgers, and the other frying, all other kinds of frying foods that can be used. We take this fuel, we access these locations. 3 billion gallons, just to put in perspective, will be enough to fill 4,500 Olympic-sized swimming pools. So that's the amount of UCO that is just generated alone in North America. All of the products that are brought into North America are 100% renewable waste and residues. And Neste has committed to making 100%, all of the global products, 100% from waste and residues by 2025. Not only are we trying to access the UCO market, the animal fat, and all this markets, and using these types of feedstocks, we are also looking towards the horizon to the tomorrow's feedstocks like algae oil, winter cover crops, forestry waste and residue, power to liquids, MSW is basically taking a trash and converting that to fuel. So not only are we looking at now, we are also continuing to innovate and continuing to look at other feedstocks that we can keep using and create a feedstock mix that is sustainable for us to keep producing these fuels. Next slide, please. So so from transitioning now from the feedstock to our technology, so Neste uses the HEFA technology, which is, as I mentioned previously, is one of those 7 approved pathways. These pathways are approved by ASTM and then they are certified by the FAA. So these pathways are very rigorous and requires a lot of testing at engine level, flight level, lab testing to ensure the safety of these fuels, to ensure that they qualify to be flown into aircraft. So going back to the technology that we use these raw materials like used cooking oil, fats, greases. We bring them into our refinery. We globally source them. Our secret sauce, I would say, for our operation is our pretreatment. This pretreatment unit enables us to take the lowest quality, the worst quality feedstocks, be able to transform them into this premium fuel every time, water liquid clear fuel every time. And through this NEXBTL process, we use hydrotreatment and isomerization. We have 4 refineries that can do this process to produce renewable diesel or renewable jet or sustainable aviation fuel. And we can produce this fuel at same quality, at same high quality every time. And once this fuel is produced, our output is in 2019 and right now is 34 million gallons of SAF is the capacity that we can make right now. And we will increase that capacity to 350 million gallons in 2022 when Singapore comes online. Next slide, please. So here, I'll talk a little bit about the chemistry side. I myself, I'm a mechanical engineer, so I will try my best to explain this. But if I don't get it right, then please do forgive me. So what we do is we take a triglyceride molecule, it is a molecule that we find in fats and oils. It is a 3-chain fatty acids, which is connected by an oxygen molecule and a 3-carbon glycerol molecule. All we're doing really is reacting with the catalyst, reacting this with high temperature, high pressure hydrogen, and breaking these red oxygen bonds and creating these strong, long hydrocarbon chains. And these are the key for us. These are the hydrocarbon chains that you would find in jet fuel. All we do is distillation. We have great partners for that. And we distill this fuel to a jet fuel range. And what I'm trying to show with this slide here is basically that Neste SAF, or SAF in general, is a hydrocarbon fuel which is exactly chemically identical to a jet hydrocarbon fuel. Okay, next slide. So we have this great fuel. It's energy dense. It is paraffinic fuel. It does not have any aromatic compounds. It does not have any other chemicals that a regular jet fuel would have. And this, what I've shown here, is a typical supply chain of one of our typical supply chains we use to produce and distribute this fuel. So we bring in the waste and residues into a refinery, we process them, distill it, send it to our blending terminals, and we procure the fossil jet, conventional jet, bring it into our blending terminal. We blend the product ourselves. We have strict quality assurance practices in place, making sure these blends will be certified to jet fuel specification, which is 1655. And once it's blended, it can be used similar to, you can use the same transportation methods and infrastructure like pipeline, marine vessels, barges, rail cars, trucks, ISO containers, drums. You can, whatever jet fuel right now uses for transportation, you can use it. You can use it without changing anything. You can use it without additional investments. We bring this fuel to an airport storage location. We can commingle this fuel with other jet fuel. We can even commingle this fuel with other SAF blends without any issues. And once it's in the airport storage, it can then be accessed by a refueler, or it can go through a hydrant system and can be accessed by the airlines directly. So it is a very simple supply chain. All from the point it's blended, it is exactly the same supply chain as jet fuel. But prior to the blend is the only place where we have to segregate the fuel. And then once it's blended, it is exactly the same infrastructure. The next slide, please. So I will conclude here. And I would like to say that SAF is ready for takeoff now. It has to be part of the solution to make air travel more sustainable. We have all these different measures, but SAF is a big part of this equation. It can be made from various renewable feedstocks. We have 7 approved pathways right now that it can be produced from. It can be produced from waste, fat oils. It can be produced from municipal solid waste. It can be produced from sugars. There's different technology available to make this. These pathways go through extensive testing regime in order to meet safety standards. All of the blends that the SAF we can make all need to meet these rigorous certifications that a conventional jet fuel would need to meet. SAF and the blends need to meet the same specifications. And it's a hydrocarbon fuel. It has no oxygen component. It is very high thermal stability, very good storage properties. This fuel is hydrocarbon fuel, and I cannot emphasize that enough, that it is safe to use in a blend form in all the infrastructure that is available to us at the moment. So with that, I would probably not too relevant right now, but as soon as you're flying again, I would like to say safe travels and remember to lower your own environmental footprint. Thank you.
Prati, thanks so much for that fantastic presentation. Remember, if you have any questions, please pose them in the Q&A. There are a couple coming in. But I want to get started with something you alluded to in your last comment about the status of the airline industry and really travel at the moment, where I was reading this morning, Delta is projecting that air travel over the summer will be 25% of what it was last year at this time. And that's a market improvement from where it was a month or two ago. How did COVID impact the scalability of SAF and Neste in particular, but more broadly, sustainable aviation fuel?
A great question, Randy. So no doubt the COVID has really impacted the aviation industry. Just recently, I read news that Qantas is laying off 6,000 employees, and I read this news every day, where there's an airline that is going bankrupt or reduction in labor and workforce. What it has also done is really created a demand destruction for jet fuel. I mean, the airline schedule has been below 90% cutoff, and it's been tremendous, put a tremendous impact on jet fuel, and it has impacted SAF as well. We have had grand plans for this year to introduce this fuel to many airlines, but because of the jet fuel demand dropping significantly, SAF has also suffered quite a bit. But saying that, we have a very positive outlook on Neste's side on these fuels. We believe that sustainability still matters quite a bit, and once this pandemic is under control, the airlines and travel will pick up again. So our plans haven't changed one bit. We continue to scale the production. We are continuing to focus on producing more. We're continuing to get a lot of interest still from the airlines who have planned or are planning to use SAF in the near future. So for us, things continue as usual. We continue to push the use of SAF, and we continue to make our plans to expand, do our expansions, continue with our Singapore project, which still scheduled to be online by 2022. So we continue as normal. And as we get through these few months, we still believe that there's going to be demand for SAF, and we will continue our scale up.
Got it. And my guess is, even if jet fuel demand is down by, let's say 75%, if the policies are right, that means that SAF could actually have a greater percentage in the overall jet mix. So
That's right.
Actually, a possibility if the policies are right, independent of what's going on with COVID. And I know there are conversations, at least in the U.S., about making incentivizing SAF as part of any stimulus packages. So it could be an opportunity for SAF, independent of what's going on with COVID. But another question related to COVID, which is about supply chain. Are there any supply chain risks, particularly for the leftover cooking oil, where I think about restaurants across the United States down and only slowly coming back online.
That's right.
People cooking at home more and not being able to collect home. I mean, I don't give my home cooking oil to Neste. If you want it, I'll tell you my address after this. But any risks to that?
Yes, definitely. We have also seen impact to that to our supply chains as well, especially used cooking oil. As you said, that a lot of the restaurants now are not open or are way below their capacity. So there has definitely been an impact, but we are also trying to manage or mitigate that with our feedstock mix. So we not only use used cooking oil, we use animal fat, we potentially can use some vegetable oils as well. So with our feedstock mix, it gives us some kind of stability in allowing us to continue our production. But no doubt, used cooking oil has definitely been impacted due to this COVID situation.
Got it. Well, I do have a jar of used cooking oil and bacon fat in my refrigerator. So instead of throwing it out, I'll mail it directly to you. So very good questions from the audience, actually related to the feedstock from Jenna. What percentage? And let's go back to pretend we're in normal times and not COVID times. But what percentage of the process costs are attributed to the collection and transportation of feedstock?
So can you repeat the question again, Randy? I think you meant to say what the cost breakdown is of
what the cost breakdown is, and so how much of the cost is attributed to collection and of feedstocks.
I wouldn't be able to tell you exactly percent-wise what the collection costs are. Our supply chain, as the way it's set up, we have collectors that we have. We just recently acquired Mahoney International, which does a lot of the collection of used cooking oils around the world. Not around the world, but in North America, specifically in US. But I seriously, I will have to take that back because I cannot exactly tell you how much of that percentage is due to collection and transportation. I'm just not on that side of things. So I do apologize, but I will definitely take that and take it back and get the answer for you.
No worries. Jenna does have another question on price, which is what's the differential right now between SAF and Jet A?
I would say, generally speaking, there is a 3 times difference, so it costs 3 times more for an SAF when compared to jet fuel.
Got it. And so you really need policy to incentivize this.
That's exactly what we need.
By valuing the attributes. Yeah. Okay. Question. There are a number of really good questions on cost, and this one is more about the supply-demand dynamics of cooking oil and waste oils.
Okay.
Which is, if you continue to consume, purchase or consume cooking oil and waste oils, will the price of cooking oil go up, and will that make SAF even more costly compared to Jet A, or does it not work that way?
No, it is completely true. The more supply, the more demand you have, the more supply. The supply gets, the more demand, and the price will go up. And that is key to what we do. Is we don't rely on a single feedstock. We have multiple feedstocks that we can use in our process. That kind of stabilizes our price fluctuations on feedstock. No doubt, if you are producing SAF, majority of the cost is the feedstock. The feedstock alone can cost more than the price of jet fuel. So it's really per ton, but it's really managing our feedstock supply base, diversifying our feedstock. That is why we are looking at all of these technologies to other feedstock technologies. Like algae oil is really, really interesting to us, but we have to do that. We have to continue to look for these additional feedstocks. We cannot rely ourselves on one feedstock and hope that that will take us through, because you're absolutely right. The price fluctuations because of supply and demand will increase the cost. So we just need to figure out a way to mitigate that with our feedstock base and mix that we use.
Fascinating. Maybe we should start a futures market for oil. So a question about Neste's plans in the United States. What are the plans for production in the United States?
I forgot to mention it in my presentation, but there are big plans for the United States. Actually, this is the year we will launch SAF in North America. We are targeting the launch sometime this year. I can't give you the exact date right now, but there are plans to start supplying SAF to major airports in California. So we are just in the process of getting that all completed. And I'm sure in a month or two, you will start hearing in the news about our supply here in North America. But we are definitely ramping up our footprint in the US.
Fantastic. Well, I look forward to seeing that. Okay, we have time for one final question, which is from James Green, which is, what is the largest obstacle to Neste's and other SAF companies scaling up?
I would say policy is a big deal, like you were talking about, Randy. The right policy is required. SAF is a more expensive fuel. In order to bridge that price gap, we need to find policies. The U.S. has great policies right now in place, LCFS, RIN, RFS. That's why it makes it a very attractive market. In Europe, there's been a lot of policies discussed right now. We have the RED II policy, and as well, there's some mandates that are being instituted by some of the countries that it generates demand for SAF. Although I think if favorable policies are there to incentivize SAF production, that is one of the main key drivers for a lot of the SAF producers, and to be able to scale the technologies and produce more of this fuel. We've been on the very advantageous side that we had a very big business. Neste also used to be an oil company that allows us to innovate and to be able to scale the technology up. But policy making is really a key, I would say, as one of the key barriers that need to be overcome.
Got it. Well, thank you, Pratik. Thank you so much for this engaging presentation. Thank you all for joining us today. Be sure to connect with Pratik on LinkedIn and follow him on Twitter at 317 Pratik. This presentation will be available on the Atlantic Council website, YouTube channel, Facebook, and Twitter. So please do share it with your colleagues. Thank you to all of those who helped put this event together, including Olga Kokova, Lauren Holland, Brianna Pistone, Jasper Gilardi, and then the Atlantic Council Zoom hero, Jackson Styron. If you're interested in learning more about sustainable aviation fuels, please check out the recent Atlantic Council Global Energy Center report called Sustainable Aviation Fuel Policy in the United States, a Pragmatic Way Forward, which is also available on the Atlantic Council website. I hope you will join the next episode of Innovation Stream on July 1st at 1:30 p.m. Eastern, where we'll chat with Oliver Cameron, the CEO of Voyage, who will present on autonomous vehicle technologies. I'll be on vacation next week, so Olga Kokova will host. And I look forward to seeing all of you when I'm back. Until then, please do stay safe and wear a mask when you see other people. Hope to see you all soon.